Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be covering the topic of Bluetooth addresses and the role they play in protecting the privacy of Bluetooth devices. The topics we'll address in this video include what is a Bluetooth address, the different types of Bluetooth addresses including public addresses, random addresses, static addresses, and private addresses, which include resolvable and non-resolvable. And finally, we'll cover the role that Bluetooth addresses play in protecting privacy of Bluetooth devices. So what is a Bluetooth address? A Bluetooth address, sometimes referred to as a MAC address, is a 48-bit value that uniquely identifies a Bluetooth device. Now there are two main types of Bluetooth addresses, public and random addresses. A device must use at least one of these addresses, and in some cases it may contain both. Here's a diagram summarizing the different types of Bluetooth addresses and how they relate to each other. So first we have two main types, a public address and a random address. A random address could either be a static or a private address, and in the case of a private address, it's either resolvable or non-resolvable. So in the end, there are four types of addresses: a public address, a static address, or a resolvable private address, or a non-resolvable private address. Now let's talk about each of these different types of addresses. First we have the public address. This is a global fixed address that must be registered with the IEEE. The address never changes, and it guarantees that the address will be unique for a Bluetooth device. The format of a public address includes a publicly assigned company ID at the least significant 24 bits of the address, and an internally assigned ID in the most significant 24 bits. Now, random addresses are more popular since they do not require registration with the IEEE, which has a cost associated with it. This type of address is either programmed into the device or generated at runtime, depending on the subtype. The two subtypes are random static address and random private address. As we touched on before, a random static address is similar to a public address but does not require registration, so it serves as an alternative to a public address. This type of address can be changed upon boot up, or it can stay the same during the lifetime of the device. It cannot, however, be changed during runtime. A random static address contains two ones in the least significant bits, and the rest are chosen randomly. A device must have either a public or a random static address. The other subtype of random addresses is private addresses. A private address has two subtypes, either resolvable or non-resolvable private address. A private address is optional and is used specifically for privacy protection of a Bluetooth device. A device must be assigned a public or random static address even if it wants to hold a resolvable or non-resolvable private address. A resolvable private address is used for privacy purposes and to avoid tracking of Bluetooth devices. It is generated using a key called the IRK, or Identity Resolving Key, and a random number. A device's resolvable private address can only be resolved by trusted devices which have bonded with this device. This address changes periodically, and the official Bluetooth specification document recommends changing it every 15 minutes. The address is made up of 0 and 1 in the least significant bits. The next 22 bits are random, and these least significant 24 bits are collectively referred to as the PRAND. The remaining 24 bits represent a hash value, which is generated using the PRAND and the IRK. The other type of random private addresses is the non-resolvable private address. This type of address also changes periodically, but unlike resolvable private addresses, this type does not allow to be resolved and is meant to prevent identity tracking by any other Bluetooth device. It is not common but sometimes used in beacon applications. A non-resolvable private address is made up of two zeros in the least significant bits, and the remaining 46 bits are chosen at random. Privacy is a major concern for users of Bluetooth devices, and it needs to be taken seriously. What we mean by privacy in this context is making sure that untrusted parties are not able to track a device by its Bluetooth address. If no careful measures are put in place, then this address can be used to track users. Fortunately, Bluetooth Low Energy provides privacy features to safeguard against such attacks. Privacy for Bluetooth devices is achieved by using a resolvable private address. This type of address requires bonding of the two Bluetooth devices in order for one to be able to resolve the address of the other. A key referred to as the IRK or the Identity Resolving Key is used in generating and resolving the resolvable private address. The IRK generated by each device locally is either chosen at random or assigned during manufacturing. During bonding between two devices, each device stores its peer's IRK in what's called a resolving list. The IRK is then used to resolve the private address of a peer device, for example when it receives the peer's advertising packets at a later time. This is done by verifying that the hash included in the private address matches the output of the local hash computation according to the following equation. Since the device has the IRK stored locally and has access to the PRAND included as part of the private address, which is included in the BLE packets, it can perform this computation. It's important to note that the IRK is not used to reveal the peer's identity address, which is either a public address or a random static address, but rather for verification purposes only. To learn more about Elysis, provider of the world's most advanced Bluetooth analyzers, visit elysis.com. Have a need for training or design services? Then contact our training partner, Novelbits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.